Welcome to the Escape Data Processing tutorial. Locate on the offline computer's desktop the Escape installation folder. Copy this entire folder and transfer it to your own computer. In your computer, open it up. Open the PDF file. This is the installation manual. Follow the step-by-step guide on how to install Escape. Screenshots are provided and the steps should be quite easy to follow. This is the window you will see in the Escape processing mode. Open up the data organizer on the left. At the top right of each window, there are two icons. One is to float the window, to dock close the window. Another is to auto-hide the window. This docks it. To reopen it, simply click on the button again. From the data organizer, close any unwanted experiments. Open your experiment file. Expand your experiment to review your samples. Expand your sample to review the sample locations. Expand the desired sample location, the measured spectrums will be shown. You will notice a wide spectrum and several elemental or narrow spectrums. Double-clicking on the sample spectrum will open a new tab which shows the results and your spectrum name. Why it is called wide is because it is a general sweep with bigger energy intervals. This is to get a general idea of the elements in your sample, but it is not for chemical state analysis. The resulting spectrum is over a very wide range but with low peak resolution. Narrow spectrums are targeted sweeps with a narrower range of energy and with smaller energy intervals. It is usually used for specific chemical state analysis. The resulting spectrum is over a narrow range but with high peak resolution. Please note that because of this difference, you should not mix wide and narrow spectrum processing. The two types of spectrum have different conditions during measurement, and therefore processing should be done separately. Right-click on the tab and click Close All to close all spectrum tabs. There are two colored tabs on the right. Click on the Modeling tab. In this data processing, it is important that this Modeling tab is selected. You will not be able to do any modeling processing from the Spectrum Result tab. On the left, you will see a few icons. The mouse button is for general selection. The left magnification icon is for zooming in or out. The right magnification icon widens or shrinks peak widths. Other icons will be covered later. Open up the modeling window. Drag a white spectrum into the modeling window. The spectrum will appear in the modeling tab. We want to do a charge offset to ensure that the peaks are calibrated to the right energy. The most common element to do this is with the carbon 1s peak, which is supposed to be at about 285 eV. Click the left magnification icon and scroll to zoom in to around 285 eV. Drag the orange or sometimes green box to align the line to the rightmost carbon peak. Double-click in the box and type 285 into the box and press enter. The resulting box will be green, the energy scale should shift, and in the modeling window, you will now see a light bulb appear beside your spectrum name. Click Save. Under Data Organizer, Charge Offset will appear under the spectrum. I will now repeat this charge offset for the narrow spectrums. Drag in the carbon 1s spectrum. Drag the orange box to the peak. Type in 285 and press enter. Click Save. To apply this narrow charge offset to the rest of the narrow spectrums, drag in the rest of the narrow spectrums into the modeling window. Note, do not use the white spectrum's charge offset on the other narrow spectrums, or vice versa. Only use narrow spectrums from the same location on other narrow spectrums. Select the rest of the spectrums by pressing Shift and clicking on them. From the data organizer, drag the charge offset into the modeling window and into the selected elements. A light bulb icon will now appear for all the selected spectrums. Click Save. The charge offset now appears under these spectrums in the data organizer. To remove the spectrums, select the spectrums and click X. Click Yes to save your modified models. Minimize the rest of the spectrums in the data organizer. Note: only for wide spectrums, we can use the data processing's peak ID function to automatically identify peak identities. These peak IDs should be automatically transferred to the narrow spectrums. Auto-hide the modeling window. Open up the data processing window. Drag white into the window. From the left list, select ESCA spectrum. ESCA refers to electron spectroscopy for chemical analysis. From the right list, select peak ID. Select the white file and click on the play button to process the selected data. The button will start to spin. It will stop spinning once it is done. Click on the button beside the play button to display the processed data. 3 processing outputs will now appear. Click on Processing Output 3. Your labeled spectrum is shown. You can click on the other tabs to see more information about your peaks. Click on Processing Output 2. This is the summary of atomic and mass concentration percentages. You can see quantified by regions or components. They will have the same value since there are no components defined in wide spectrum. Note that the values are all normalized to sum to 100%. Regions are with respect to the general elements. Adding components will help to break down these elements into more specific orbital or chemical states. For example, splitting the 2p region into 2p 1/2 and 2p 3/2 components, or carbon 1s region into CO and CC bond components. Adding of components are usually done in narrow spectrums as the peak resolution is better. How to add components will be covered later. Click on Processing Output to check the regions identified. If there are any regions missing or wrong, proceed to the next part on how to manually correct or identify regions. Click on Save. A peak ID line now appears below the spectrum in Data Organizer. Wide spectrum processing is now done. Close all the spectra and hide the data processing window. To check whether the right peaks were identified, open up the modeling window and drag the spectrum into the window. Note, if peak ID was not done in white, there will be no peaks identified in the narrow spectrums. Select regions. You will now see the elements that have been automatically identified. These elements will have a black line, the area is grey, and the automatically identified name will be below the peak. The peaks are ordered from lowest binding energy, which will be the rightmost on the scale, to highest binding energy, which will be the leftmost on the scale. You can check the start and end for the positions of the peaks. I will now continue using the narrow carbon 1s spectrum as my example. If there is no light bulb seen, drag the charge offset beside the spectra name and make sure that a light bulb appears. This means that charge offset has been applied. Sometimes, the system is unable to identify the element. To check what element it is, click on the wavy line with the green lines. This is to add element lines. Click and drag over the peak you wish to check. Suggested elements which fall into that peak will appear at the bottom left. Left-clicking once displays the element's predicted peaks in red, with its expected peak heights displayed as the line heights. You can move the box up or down for easier comparison. Hovering over the box and scrolling up or down increases or decreases the red line heights. Left-clicking twice removes the element and its lines. If you have a specific element in mind, right-click on the red box on the left and select Periodic Table. Select your element from the periodic table. If the element falls within the peak range, red lines will appear. When you are done, click on the icon with the X sign. Click and drag over the area to remove the element lines. If you wish to add a peak, select the icon with the grey curve. Click and drag over the area of the peak. a new column will appear. To change or identify the element, define the line. Click on the line row and then the question mark icon. A window will appear with a scale and suggested elements in blue. The grey area is the range your peak falls into. Select a suggested element by left-clicking on it and selecting the relevant element. The line row will be updated. You can scroll left and right to see the other suggested elements at a range of peak values. If you do not see your element, you can try clicking on the box beside elements. This will show a periodic table. The element's peak position will be shown on a scale if it falls within the range. Select it by left-clicking on it. Define the name. The peak name in the spectra will update. Do adjustments to the peak if needed. To do these adjustments, click on the mouse button. Click on the black line and click on the round button. This will bring up two circles at the ends of the line. Adjust this line such that the grey area fully covers your peak area. There are three types of algorithms: linear, Shirley, and Tougaard. It is recommended to use Shirley algorithm. If needed, go to Model and change the average to 5 points. This may make it easier to get a better baseline when the background is very noisy. Sometimes 0 points also works. 5 points usually works better on narrow spectrum and 0 works better on wide or small peaks. If you wish to delete a peak, click on the mouse button and hover over the alphabet. Click on the X to delete it. I will repeat the steps to add back my peak. If you still wish to add components for narrow spectrums, you can click Save after doing components. Otherwise, you can click Save now. A model fit line will appear under the spectrum. Similar to charge offset, you can apply this region's fitted model to other spectrums after saving. This is especially useful for depth profiling, where you get many similar spectra. Note: do not apply a wide spectrum model on a narrow spectrum or vice versa. Under Data Organizer, expand the model fit line. You will see a fitted model line. Drag the rest of the spectrums into the modeling window. Select the spectrums and drag the fitted model into the spectrums. You will see a grey curve icon appear. Click on the play button to auto-fit the model. If you save it, you will see a new model fit appear under the other spectrums. Delete the other spectrums from the window. You are now done checking regions. Drag your narrow spectrum into modeling. To make sure the charge offset is applied, drag the charge offset into the window. A light bulb will appear beside your spectrum name and the folder icon will disappear. Only for narrow spectrums you can add components to your peaks. Click the green and red curve icon. Clicking on a peak will automatically generate a simulated peak. A new column will appear under components with the peak name and peak position. In this example, I know that my carbon 1s peak will likely be made of the CC bond at 285, COC bond at 286.5, and OCO bond at 288.5. I can then proceed to add these three components into the C1s region. To delete a peak, click the column alphabet using the mouse button and select the X icon. You can drag over a specific area to manually define the peak width. If there are multiple components in one area, a black dotted line will appear which simulates the sum of the component peaks. You should try to make this black line fit to your actual spectrum line in blue as best as possible. Use the mouse button to adjust the peaks. Click on the peak and the circle icon. The circle on top adjusts the peak height. The circles at the side adjust peak width, and the circle at the bottom moves the peak position. To fix any parameter, go to the line below with the squiggly line and enter in space. In this case, I know the peak energies that I want to use, so I will fix them. Usually, components of the same element will have the same full width half maximum, or FWHM. Since these are all carbon, the peak should be of the same width. To fix the widths, under the line below FWHM, if you wish to use column A's element as the reference width, under the desired column, example column B, key in A and space. A number multiplied by A will appear. Change the number to 1 and press enter. This now sets column B width to be 1 time of A's width. To fix the heights, do the same for the area percentage line. The general area ratios are P1/2 is to P3/2, 1 is to 2. D3/2 is to D5/2 is 2 is to 3. And F5/2 is to F7/2 is 3 is to 4. See that the heights now move together in a fixed ratio to each other. To fix the distance between peaks, do the same for the peak energy line. To delete any fixed row, go to the line, delete the setting and click Away. I can now change the row to fix the distance between peaks. See that the peaks move together with a fixed distance between them. I will now do some adjustments to fit the peaks nicely. Click Save to save the components. A new model fit line will appear. Similar to charge offset and regions, you can drag and apply component fitted model to other spectra. Delete all the spectra and hide the modeling window. To do quantification of your new regions and/or components, open up the data processing window and drag in your spectrum. Select XCAR Spectrum and Quantification. Click on the play icon and then display the results. Notice that the region is based on the line name and component is based on the name given in modeling. You can also quantify your elements in relation to other elements. Drag in the other spectra and select them together. Click Play and display. The relative percentages are shown. Save the results if you wish. A process line will appear and with quantification as the subline. If you wish to export your data to Excel, follow the steps in the installation manual to install the Microsoft Excel add-in. This is located in C Drive, Program Files, Kratos, Escape folder. The file name is Kratos Excel Add-in VSTO. Once you have finished installing the add-in, open up Excel. Go to Data, click on the Kratos sign labeled Experiment. Open your experiment file. Your experiment details will appear under the experiment browser on the right. Open up the data that you want. Select your desired data and click Import below. Your result will be transferred to the Excel sheet. A new sheet will be created for every import. If you wish to import your spectrum, click on the spectrum name and click Import. Your spectrum graph, together with the counts per second at each binding energy, is displayed. You can choose different kinds of data to import. Note that each type of data imported creates a new sheet. You can edit the graph just like a normal graph. For example, you can change the graph size and the axis properties. Take note of the data imported. This fitted model was where I had only done regions edit, which is why there is a grey line but no components. This second fitted model was where I had done components fitting and therefore both the grey line and the green components appear. Proceed to save the data as you wish. Basic data processing is now done.